Hello and welcome back to California Geology. I am Dr. Robert Lopez, and today I want to talk about the transverse ranges, chapter 16 in your text. But before I do that, I actually need to talk a little bit about geologic structures. So we look over here at our document camera. So a geologic structure is they're really the architecture of Earth's surface. We're going to try to document the folding, the faulting, and how it relates to how these structures intersect the land surface. And often we're putting these structures on maps which are two-dimensional. So we're trying to show the third dimension with symbols in terms of geologic contacts. And really the more important symbol we use is a symbol called the strike and dip symbol. And strike and dip relates to the attitude of the geologic structure. For example, here I have some strata, and I'm trying to show that they're inclined off toward the east over here. So this would be east, and this would be west over here. And so if they're inclined toward the east, the strata are striking in this direction, and they're dipping or inclined off toward the east. And so here I have a fault, some horizontal strata, so a variety of features. In fact, let's first look at the strike, and we'll define what strike is. So strike here is a horizontal line on a geologic surface, and we always have it in reference to north. So it's really a compass bearing, but you always want to reference in the northern direction. So here, for example, would be a horizontal line. This is a strike line. And then and it's inclined or dipping back in this direction, because if we could measure from the horizontal, we can measure that dip direction right there, that angle we're trying to measure. So if I look at my my little model here, these strata here, the yellow, gray, and red, they're striking parallel to the contact between these formations. So the contact is between each of these units, and then it's dipping back, in this case, off toward this direction. So if I could draw a small T symbol, the strike line going here, parallel to the contact, then with a little dip direction going off in that direction there. So we'd have a strike and then a dip in that direction, because that's the way the strata are inclined. So if we go back over here, so the strike line, remember I said it's a compass direction. So here I have this strike symbol, and I can see if this is north, I can measure the angle from north, and I get about 45 degrees. So the strike of this line is north 45 east, and it's dipping off in the southeast direction. That's how we measure the strike and dip. So usually these symbols, this symbol that you see here, will always indicate the attitude of the bed. In this case, this symbol tells me that the bed is striking in that direction. So but it's inclined back toward the bottom of the page here. And so you can see the inclination going back in that direction here. So if I could draw in here, I would draw a strike line here. So there would be the strike direction. And then it's inclined back in this direction here. So let's see if I can see it better in here. So there it is. We'd have the strike direction here, and then the dip right in here. So the strike and dip. So again, it's telling you the structure of the geologic units there. So now let's see how we're going to, in fact, here's another example. A geologic contact is a contact between two rock units or formations, like I was showing in my little diagram there. And strike usually is parallel to the contacts, just like I drew it on my little block diagram over here. Now here's another little one that I've drawn, and so same idea. I got some sand, shale, limestone, and here are the contacts between these formations. Here's another shale, and I see the strike dip symbol. The strike is parallel to the contact, and here the dip is showing that it's dipping off in this direction here. So strike and dip. And remember, another key point right here is that dip will always be perpendicular to strike. Dip will always be perpendicular to strike. Now, let's see how we're going to make some geologic folds using what we know about strike and dip. So one thing about folds will always result from compression. Just like if you're running down the hallway if we still run down the hallway, and you slide on the mat, if it's a slick floor, the mat may get these folds in it. It'll wrinkle, and you'll get a series of upturned folds and U-shaped folds, right? And we're going to make those folds, and we'll define what they are here. So using my strike and dip symbols here, note that the strata here, at least at this contact, tells me that it's inclined back toward the west over here. So usually when we're looking at diagrams, west will be on the left, east will be on the right. So in this case, we're going to have this unit inclined back toward the west here, right? We'll come back to this symbol here. This is a different symbol that I'll introduce in a moment. And then these strata here are inclined toward the east. So we'll have this going down a little bit. Let's go a little bit down there, and this one's also going down in here. Now, but this one over here is inclined back toward the west. So we're going to do something like this. And so we're going to have this guy come right up in here. So what I'm drawing here, I'm drawing some geologic folds. And I also want to show the geology along the side of the block over here. And there's probably an older unit in here that's going to also be folded as well in here. And then maybe we'll put one more here. So I'm seeing, just from the strike and dip symbols, I'm seeing that these strata are inclined away from the center. These are inclined toward the center. So I'm making two distinct types of folds. In fact, this kind of arching fold here, this one's called an anticline. Anticline. So the anticline is an arching fold, whereas this U-shaped trough-like fold is called a syncline. So there's syncline and anticline. Note that I got the strike and dip symbol for inclined strata, but I also have this symbol here, which is for horizontal strata. And note that right in here, as the strata, see the strata is inclined toward the west, then it's inclined toward the east over here. Well, right in the middle, it should be horizontal. So that's why this region shows horizontal strata there. Same thing here. It's inclined toward the east, then it's inclined toward the west. So right here should be the horizontal strata. So this region really defines the inflection point of the fold. And we call this inflection point the axial plane. Axial plane. So that axial plane bisects the fold. Here's another axial plane for the anticline. So we'll put the axial plane going right through the middle. So we'll put this AP for axial plane. Also note that we have a special symbol for axial planes. So for the anticline, we usually show two arrows pointing away from the axial plane. For synclines, we'll show two arrows pointing toward the axial plane. So that's telling the reader that that's a fold, a syncline, and that's an anticline. So if we look at the symbols that I've drawn down below here, there's an axial plane for an anticline, axial plane for a syncline. So just for that, we made our block model here showing compression, squeezing this. We're folding the strata, making an anticline and a syncline. So just remember, anticline is an arching fold, syncline is a trough-like fold. The other important thing about anticlines and synclines is along the axial plane, you're always going to have older rock at the axial plane. So here, this strata is older down here, and it's at the axial plane. But for a syncline, note that the younger rock is at the axial plane. So here we're going to have younger rock at the axial plane. So when you're looking at synclines and anticlines, you often have an age connotation, meaning that an anticline will always have older rocks near the axial plane, and as you move away, they're going to get younger. On the other hand, the syncline will have the younger rocks at the axial plane, and as you move away, they're going to get older. So there is some stratigraphic significance as well.